Hello friends, very good evening. Today our topic is cyclotron. Right? It is a device based on the simple principle, right? That if a charged particle is moving perpendicular to the magnetic field, it acquires a circular path. Actually, it is an accelerator devised by D.H. Lawrence in 1932 to accelerate positive charged particle. So far as its construction is concerned, it is quite clear. It consists of two semicircular metal D, right, which is connected to a radio frequency oscillator, which produces a very high potential difference of the order of 10 to the power 5 to 10 to the power 6 volt, and with a frequency 10 to 15 megacycle per second. This system, on both sides of that, a perpendicular magnetic field produced by the electromagnet is applied, and a positive ion source is placed between the gaps of two Ds, which I have represented here as plus S. This positive ion source consists of either hydrogen or deuterium to produce the positive ions, proton or deuteron, right? This is the basic construction. Now, so far as its principle or working is concerned, so when this electric field is applied, what will happen? The charged particle will acquire a force on it, right? So far as principle is concerned, we simply write it down like this, that when a charged particle is passed through an electric field and magnetic field repeatedly, then it acquires a very high velocity. What I am saying, when a charged particle is passed through an electric field and magnetic field, repeatedly, then it acquires a very high velocity. Now, what will be the working of this one, right? Now, what happens? When positive charge is placed inside an electric field, it experiences a force which produces an acceleration, and the particles acquires a velocity. This is the main function of electric field. Once the charged particle acquires a velocity like this, which I am representing here, which is perpendicular to the applied magnetic field, so our magnetic purpose comes into play. When a charged particle moves perpendicularly inside a uniform magnetic field, what happens? It acquires a circular path. Right? By using the same process, the centripetal force is provided by the magnetic force. What we get? R equal to mb by QB. Right? This will be the radius acquired by the charged particle. Now this work of this oscillator comes into play. As first what happened, the charged particle is entering in the D1D. Suppose in the first half D1 is negative and D2 is positive. So what will happen? This charged particle will be attracted toward D1 and it will move perpendicular to the magnetic field. It will acquire a circular path like this one of radius r. Right? As soon as this particle completes its semicircular path, the polarity of D changes. It becomes positive and now it becomes negative. So what will happen? This charged particle will be attracted towards D2 with a higher velocity or higher radius, you could say, like this. Same process will take place and it keeps on going continuously by increasing its radius, and ultimately we acquire the maximum radius here, which I could denote it here. We say R max. And charged particle acquires a maximum velocity and maximum kinetic energy. That is the simple working of this. Right? Now what will be the time taken by the charged particle to complete semicircular path? Time taken by the positive charge to complete its half cycle. Why I am saying this? Because after half cycle the polarity of D is interchanged. So what will be that T half? That will be half of the circumference divided by the velocity. So what we will get? If we substitute the velocity rate formula here, pi via V into R is nothing but mb via qb, what we will get? T half will be, the time taken by it will be pi m upon qb. Right? If we just go through this one, what we will find out? This T half, this half cycle is independent of velocity. Remember this one, most of the time it is asked. Velocity of the charged particle. So on which factor it is depending? T half depends on, if you remember this is called m via q. Right? This is the basic principle of this one. So what will be the maximum radius of this one? Or first of all, what will be the frequency of resonance to produce this acceleration? T was what? 2 pi r by v, which comes out to be 2 pi m by qb, right? And n frequency nu is nothing but reciprocal of time period. It comes out to be 2 pi qb by m, right? This will be the resonant frequency. How to adjust this? So what we do here, we simply adjust the magnetic field. Initially we apply very high magnetic field. B applied is of the range of 1.6 Tesla. So in order to acquire this ratio, this nu zero, we just change the magnetic field, nothing more than that, right? What will be the maximum radius which we were talking about? So what we got is T half is pi r by a v, right? And it comes out to be pi m upon qb, right? If I want the radius r will be what? T half into v by a pi. Substitute the value of v, what we will get? If you are having problem, you can just equate like this: mv square by r is equal to qvb. So v comes out to be r qv by m, right? So when this r maximum is obtained, r maximum, then we can calculate ke maximum will be half mv square, right? If you substitute the value, it comes out to be half mv is r cube. Now r I will write down maximum. The maximum is radius which it has acquired, its whole square. Then what will be the Ke acquired by the charge particle? Ke max comes out to be 1/2. M will be cancelled. It will be Q square B square by M into R max square. This will be the kinetic energy acquired by this cyclotron, right? Though it is an olden age device, but it is still used for the disintegration purpose to increase the velocity of proton or deuteron, right? Now one more thing is that we are saying it can accelerate the electron, or proton and deuteron. Why not electron? So this is the limitation of cyclotron. A cyclotron cannot accelerate an electron. Question arises, why? Right? So far as rest mass of electron is concerned, if you do know that, it is 9.1 into 10 to the power minus 31 kg, and fundamental charge is 1.6 into 10 to the power minus 19 coulomb. If you calculate M by Q ratio, ME ratio, it comes out to be very small, right? So what will happen if it is like this? An electron can acquire a velocity of the range of velocity of light. In cathode ray property, if you have read, an electron can acquire a velocity of the range of velocity of light. Then comes the Einstein's theory, which says that if a particle can acquire a velocity of the range of velocity of light, its mass will vary according to this formula: m0 under root 1 minus v square by c square. If you do remember this one. So if v approaches to c, what will happen? M will become m0 by 0, that is infinity, right? So the existence of electron will not be there. And one more exception, you can say that the velocity, the radius will become so high that it cannot remain within the cyclotron. So that's why a cyclotron cannot accelerate an electron inside a magnetic field, right? It is simply used for proton and deuteron. Thank you and have a nice day.